Good morning, and welcome to the segment of What the are systems of linear equations? That is a really good question. Let's go investigate. You ready? Yup. So systems of linear equations are linear lines that have some sort of relationship, and it's our job to investigate what type of relationship that's going to be. So there's a couple solutions that linear equations will have. They're going to have either one solution, they're going to have no solution, or they're going to have infinitely many solutions. Now, how we find that? There's three different ways. The first one is going to be graphing. So if we graph equations, we're going to graph one line and we graph the other, we would find that they intersect at one point. That's what we call one solution. Let's just say we graph another set of linear lines and we find that they are parallel, meaning that they never touch, so they're going to have zero solutions. The third way, or the third type of solution, is we graph in this, and we graph it again and we find that it's the exact same line. That would mean that that's infinitely many solutions because they touch at all different points. So we have one solution, zero solutions, or infinitely many solutions. Let's investigate the other two methods. The second method is called substitution. And again, I have two equations here and it's our job to find out the relationship between them. By substitution, if you notice, I have 2x plus 5 is equal to that entire y value, meaning that I can substitute that 2x plus 5 for the y value in the second equation. Doing that will give me 3x plus 2 times that 2x plus 5 is equal to 24. I distribute the 2 to get 4x plus 10 is equal to 24. I can now combine the 3x and the 4x to get 7x plus 10 is equal to 24. Subtracting the 10 to the other side gives me 7x is equal to 14, meaning that x is equal to 2. Now that I have x is equal to 2, I can go ahead and plug that into either one of the equations, whichever makes it easier. I plug it into the first one, giving me y is equal to 2 times 2 plus 5, meaning that y is 4 plus 5. Combine those, y is equal to 9. Now I know that x is 2, y is 9. That's the point on the coordinate system where the graphs intersect. I want to show you a different type of situation here where I'm going to solve it using substitution, but my answer is going to be a bit different. Again, the 3x plus 1 is equal to the y, so I substitute that for the y value of the second equation, giving me negative 2 is equal to 6x minus 2 times 3x plus 1. Distribute the negative 2 to give me that second line. And what I'm going to do is I'm going to combine the 6x and the 6x, which gives me negative 2 is equal to 0 minus 2. Add the 2 to the other side and I get 0 is equal to 0. Now, this means I have infinitely many solutions because 0 always equals 0. I can get 1 is equal to 1, maybe I can get 2 is equal to 2, but if I get a situation like this, I have infinitely many solutions. And let's talk about how the graph of that's going to look, okay? Because I have infinitely many solutions, that means that the lines are always touching at every single point, so they're the same line. The next method that I want to introduce is elimination. It's a bit tricky, but really not that hard. The idea is that I want to get the same value for one of the variables. So on the second equation, I'm going to multiply everything by 2 because I have a 2x on top. Doing that, I have the first equation, the same one, and the second equation is now going to be 2x plus 2y is equal to 2. And now what I want to do is I want to subtract the first equation from the second equation. I'm going to get 2x minus 2x is 0, 4y minus 2y is 2y, and then 6 minus 2 is going to be 4. Dividing the 2 to both sides, it gives me y is equal to 2. Now that I have that y value, I'm going to plug that into either one of the equations. And I plug it into the first one. That gives me 2x plus 4 times 2 is equal to 6. 2x plus 8 is equal to 6. Subtract the 8 to the other side. Gives me 2x is equal to negative 2. And now I have x is equal to negative 1. Now I know that the equations intersect at the point negative 1, 2. And graphing the lines, they look kind of like that. So that means that they intersect at a point. Let's talk about another situation. So here I have a very similar problem and I'm going to solve it using elimination. So I'm going to try to get the 2x on the bottom equation. And solving it, I get the first equation and on the bottom I get 2x plus 4y is equal to 2. I'm going to subtract the bottom from the top and you're going to notice that I'm going to get 2x minus 2x is 0, 4y minus 4y is 0, and I get 4. On the right side. So 0 is equal to 4. That can never happen. 0 never equals 4. That means that I have no solution for this equation. If we look at the graph, one graph goes this way, one graph goes the other way. You notice that they're parallel, that they never touch. There you have it. I I hope that you learned something today. I hope that you attempt some new problems. If you have any questions, feel free to message me. I will talk to you soon. See ya.